Hi there, this is Ms. Page, and I am glad that you are with me today. In this lesson, we are going to talk about how to graph quartic functions using our knowledge of transformations. In our prior knowledge, we have taken integers such as these from -2 to +2 and raised them to many different powers. Here we are raising them to the fourth power, and that is because quartic functions, the highest power of x they have is x to the fourth power. And so we know if we raise each of these to the fourth power, we will be getting 16, 1, 0, 1, and 16. For a quartic function that we can graph using transformations, the parent function has the key points where these integers from -2 to 2 are the x values, and the powers are the y values. And those would be the points then that we are transforming. So that we're looking at here, we have a quartic function. So here is one form of our quartic function that we can graph using our transformations. Notice the exponent here of 4. And this is our parameters of a, h, and k. We can also graph this structure using transformations where we have our parameters of 1 over b, h, and k. And again, that power of 4 tells us it's a quartic. This is going to be important because, as you recall, in the previous lesson, we graphed cubic functions, and that exponent was a 3. That's going to tell us what the key points are that we need to transform to graph the correct function. So here we have our x's, which are from -2 to +2, the integers. And those are the same x's that we used for the cubic functions in the previous lesson. But the y's are different because now we have x to the fourth power. So raising each of those x's to the fourth power gives us these y's, 16, 1, 0, 1, and 16. And that's the things that we were looking at in the prior knowledge. Another thing I want to remind you about is that I don't want you to try to memorize these points. I want you to know how they're constructed by the fact that if it's a quartic function, that we're taking these x's, and we use these because they're simply the nicest numbers to use closest to the origin, and we are raising them to the fourth power because we're dealing with quartic functions. Also remember that when we are graphing with transformations, we want to do the transformations that involve multiplication first, which means we do any reflection, a stretch, or compression first. And then after that, we can do translations in any direction, which technically involve then the operation of addition. All right, let's take a look at a problem. So here we are going to be graphing using our transformations. Here is the function that we're going to graph, and we can see there that fourth power that tells us it's a quartic function. And then we have a part B, like we did with our cubic problems at times. Determine the zeros, or if we can't figure out exactly what those zeros are, the intervals of the consecutive integers where we do have a 0. One thing I want to point out about quartic functions, going back to the parent graph here, is that with these, they're here in the parent function, there is 1, 0, because the vertex of this curve is on the x-axis. But if we drop that down, remember we will have 2 zeros. And if that vertex were to be above, then there would be no 0. So there's those options there. Whereas with the cubic functions, because of their end behavior, looking something like this, they always had to have 1, 0, because they would always cross the x-axis one time. All right, moving back here. So we want to identify our transformation. So this 2 is our a parameter. It's positive, so there's no x-axis reflection. The absolute value of 2 is still, of course, 2. So 2 is greater than 1. That means we have a stretch. Because we're dealing with our a parameter, it is a vertical stretch. Then we can go to h and k. H would be the opposite of this -1, so we get h is 1, which means we will translate to the right one. And k would be this +2, which means we'll also translate up 2 units. So remember that the points that we use and transform, the x's are always going to be, for these problems, the integers from -2 to +2. but the y values are dependent on the type of function. So this is a quartic function. X is to the 4th power here. So that's how the y's are constructed for the parent function. And so negative 2 to the 4th power is 16, negative 1 to the 4th is 1, then we get 0, 1 to the 4th power is 1, and 2 to the 4th power is 16. So we have to make sure these are the points that we are transforming for this quartic function. So we have here 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30 squares. We have a vertical stretch by a factor of 2. 2 times 16 is 32. Not quite enough squares for us to use a scale of 1 unit on our y-axis. So we will change that to a 2-unit scale. X-axis, I want to use a 1-unit scale. My other option is a half-unit scale. If you wanted to do that, you could. So I'm going to drop this down pretty low because even if I use a scale of 2 units, I'll need at least 16 squares, plus I have to go up 2, so that's actually 17 squares above. So I'm going to drop this down pretty low. And then I am going to put some numbers. Remember, if we change our scale to anything other than 1 unit, numbers to indicate that scale would be required. So this is 2, 4, 6, and so on. So this can take a little bit of time, but it is necessary. It's 28, there's 30, 32, and I know I'm going up to 34. But if you're not sure, you can do the whole thing. Then I'm going to use a scale of 1 unit for my x-axis. This would be 1, 2, negative 1, negative 2. And we are going to translate 1 unit right, so we're probably going to end up over here at 2 plus 1, which is 3. So that's what I'm looking at. So I'm going to take my first point of negative 2, positive 16, which is here. So we have that stretch factor of a 2. 2 times 16 is 32. So it stretches to 32. And then it moves right 1 unit. Yep. So I would put it here. And it moves up 2 units. Remember, pay attention to scale here. 2 units up would be only 1 square, because 32 plus 2 is 34. So that puts our leftmost point right there. So now I'm looking at the point negative 1, 1, which I've realized is right here. And it's going to stretch. 1 times 2 is 2, so it stretches to here. Then it moves 1 unit to the right, which would put it on the y-axis, and it moves 2 units up. 2 plus 2 is 4, and that would put it right there. Then 0, 0, not affected by the stretch, but it does move 1 unit to the right and 2 units up, which puts it at 1, 2. Then we have the point 1, 1, which would be right here. 1, 1 is, whoops, actually no, it's right here, 1, 1. Be careful about that. X is 1 here, but Y is 1 there. Then it's going to stretch by a factor of 2, which would put it here. And then it moves right 1 unit here, up 2 units. And the nice thing about the quartics of the type we can graph here with the transformations is there is some symmetry here, similar to our quadratics where we have a parabola. And although you might be thinking this is a parabola, technically it's not, because it's x to the 4th power. X squared is what we call a parabola. And then 2, 16. So here's 2, 16. That's going to stretch to 32. Then it's going to move right 1 unit and up 2 units and end up right here. So now then we can draw in our curve, which is still roughly U-shaped, just not mathematically, technically a parabola. It is rounded, remember, U-shaped. And then put arrows on the ends as we move out into the next space. And that completes the graph. So in this case, for part B, determine the zeros, we see that this particular function does not intersect the x-axis at all, and it never will because its end behavior is to positive infinity. So for our B part, we would state that there are no zeros. And that finishes up both parts of this problem. All right, we're going to look at another example. Here we go. So here is the function that we're going to graph this time. So with this one, we are looking at, again, this negative 1/2 being times our x to the 4th power, not inside parentheses with the 4th on the outside. That is a. So our a is negative 1/2. And being negative, that means we're going to get an x-axis reflection because it's all about a here. The absolute value of our a of negative 1/2 is positive 1/2, which is smaller than 1. So that means a compression. With a, that means a vertical compression. And with a factor of that 1/2. So that's all that's going to give us. And then we have to realize this plus 4, which is after the power of 4, would be identified as our k. So k is equal to 4, which means we're going to translate up 4 units. All right, so now what we're looking at here is, again, I'm going up 4, and I have a vertical compression. Nothing is going to affect x, so I'm just going to put my y-axis in the middle. And I do have that reflection, though, which is going to make all of my points head down, and then they're going to move up 4 units. So I need 4 squares, because I don't need to do a scale of 2 here. I would use a scale of 1. I'd only change my scale to 2 if I had a big vertical stretch. So I'm going to put my x-axis up here towards the top, but still leave some space. So I'm again looking at 1, 2, 3, 4, and then this would be negative 1, negative 2, negative 3, negative 4, and so on. And this would be 1, 2, 3, 4. This would be negative 2, negative 4. All right, so now those points. Again, we're dealing with quartic, x to the 4th power. So our x's are the integers from negative 2 to positive 2. The y's will be calculated by taking that x and raising it to the 4th power, which gives us the 16, 1, 0, 1, 16. All right, so let's start with our negative 2, 16. So my negative 2, 16 doesn't fit on the graph, but if I do my reflection first, it's an x-axis reflection, so that's going to flip it down to negative 2, negative 16. And then the vertical compression compresses that 16 units down here to half of that, because my factor is a half, and half of 16 is 8, so that compresses it to negative 8. And then it moves up 4 units. So now I count up 4. 1, 2, 3, 4. And there's where that point's going to end up. Now I have negative 1, positive 1. So here you could do it either way. You could reflect and then compress, or you could compress and then reflect. And so if I reflect, it flips down to negative 1, then compresses by a half. So now it's right there in the middle. And then it moves up 4 units. And remember, this would be units, not lines, so it goes 1, 2, 3, 4, and ends up right there at 3.5 for the y value. Then we have 0, 0, which is not affected by the reflection or the compression, but it does move up 4. 1, 2, 3, 4, and that's actually our vertex. Let's see if I can get it to make a point there without that line. There we go. And then 1, 1 is going to reflect to negative 1, compress to half that, count up 4. 1, 2, 3, 4, right there. And then 2, 16 reflects down to negative 16. Half of 16 is 8, so now it's at negative 8, and then it moves up 4. 1, 2, 3, 4. And there is a graph of this quartic function. That's not the best curve. Let's start here. It might be a little easier. There we go. Oops, I don't like that one. There. So now, part B, this time, what we have to realize is that our zeros are going to be here and here. So this is the interval for this left side 0 from negative 2 to negative 1. And this is the interval where the second 0 is from positive 1 to positive 2. Remember, intervals always go from least to greatest, left to right. So for our B part, the zeros, plural, because there's more than one, are in the intervals, plural, from negative 2 to negative 1, and from 1 to 2. And that would finish part B. All right, the next step is a practice problem for you to try. So after I change the screen, you can pause the video, give it a try, and then I will pull up the answer afterwards so you can compare. Here you go. Pause the video, give this one a try. All right, so let's take a look at this practice problem. So here we go. So here we have A is, well, that's not right. This is supposed to be a 1/4. It is graphed correctly, but that is wrong. That should be a 1/4. So here what we've got is 2, 1/4 and 1, 4, 5, 4, and 4, 1/4. And the 0 is actually the vertex. So you'd say the 0 is 3 because you can actually tell what the 0 is. It intersects the x-axis at 3, this value right here. All right, let's move on. We're going to do a couple more examples. This one now, we have to recognize that what we're dealing with here is because the 2 is times the x inside the parentheses and the 4 power is outside the parentheses, that is our 1 over b parameter. So our 1 over b is 2, which has a denominator of 1. So its reciprocal, b, would be 1 over 2. It's positive, so we have no y-axis reflection. Its absolute value is still 1/2, which is less than 1, so we'd have a compression again. But this time, the type of compression we get with our 1 over b slash b parameter is horizontal. So we have a horizontal compression. And then, again, this -1 being after the quantity to the 4th power would be k. And so we get k is -1, which means we're going to translate down 1. All right. So I'm not going to write the points again. We've talked about them twice now as far as what they would be, and I think you can refer back if you need to as we're talking about this one. So the horizontal compression makes me really want to use a half-unit scale from x because that will help spread stuff out because the compression is going to squish things horizontally from left to right closer to the y-axis. Down 1 is going to, I don't have a reflection, so all of those points, those 16s, are just going to move down 1. That's it. So I want to make sure I've got at least 15 squares above my x-axis. So I'm going to move my x-axis down here. And I don't really have to worry about, I'm going to put the y-axis in the middle. I don't have any translations left or right. So this time my x-axis, I'm going to use that half-unit scale. So this would be a half, this would be 1, 1.5, 2, 2.5, 3, that. And then this would be -1/2, -1, -1.5, -2, -2.5, -3. For my y-axis, no reason to change the scale from anything other than 1. So we're going to go with 1s. 1, 2, 3, 4, and so on. All right, so let's go ahead and might want a little bit of numbers down there. Start graphing. So that first point is -2, 16. So horizontally, this distance to the y-axis is what's going to compress by our factor of a half. This is 4 units from the y-axis. So half of 4 is 2. So it compresses to, well, actually it's right here. Yes, yes. So we are looking at 2 units, 4 squares. So that compresses to half that, which would be 2 squares or 1 unit away, actually. And then it moves down 1 unit and ends up right there. So then we have -1, 1. So I got to watch my scale here. Here's -1, 1. So this horizontal distance is going to compress to half that. So it ends up right there and then moves down 1 unit, which would be here. 0, 0, not affected by the compression, just moves down 1 unit to 0, -1. Then we have 1, 1, which would start here, and this horizontal distance would compress to half that, and then it moves down 1 to here, which makes sense. We've got a little symmetry going on there. Then we have 2, 16, and that horizontal distance compresses to half that, which would be 2 squares or 1 unit, and then moves down 1. So you see, it kind of spreads things out, makes it easier now for me to graph my curve, connecting all of my points. Here, for some reason, there is not a part B listed, but I want to talk about it anyways, if I can get this curve to do what I want it to do. Finally. So in this case, we can actually tell exactly what our zeros are here and here, and that would be positive 1/2 and negative 1/2. So given if we had a part B, for some reason it's not listed here, but I want you guys to know that we would say the zeros, plural, are negative 1/2 and positive 1/2. Like so. All right, we've got another example. Let's take a look at this one. All right, so in this one, we are again looking at graphing using transformations here. All right, so here we are looking at graphing this function, and there was an error in the previous one, so if necessary, write this correctly. Notice our exponent of 4 here. That tells us it's quartic, which makes our quartic function f of x equals x to the 4th our parent function. So inside our parentheses then, because this 1/4 is times our x quantity, but inside the parentheses, we recognize that as our 1/b parameter. And so its reciprocal b would be equal to 4/1. And here what we're looking at then, which is 4. 4 is positive, so there's no y-axis reflection. Its absolute value is still 4, so we compare that to 1, which is greater, which means we have a stretch. Because we're dealing with our 1/b/b parameter, that means our stretch is in the horizontal direction. And then the +3, which is directly after the x, that tells us this is our h situation, so the opposite of this will be the correct h value. So our h is -3, which means we also have a translation to the left. So here's what we need to kind of think about to hopefully get our axes in the right place so that everything gets graphed on this graph. So everything we're dealing with is horizontal, which is only going to affect x. So those 16s are not going to change, the 16s for y. But the 2 and the -2, they're going to be stretched horizontally. So we're multiplying each of them times our factor of 4. And 2 times 4 moves it to 8. -2 times 4 moves it to -8. And then they're each going to shift 3 units to the left further. So that's like taking -8 plus another -3, which is -11, and taking 8 plus a -3, which would be +5. So we have got to make sure that we position our y-axis so there are at least 5 squares over here on the right side and at least 11 over here on the left. So I think if I put it here, I'm going to double check, but I think this could be a good spot because I have 6 squares to the right, so that's good. And then 2, 4, 6, 8, 10, 12 to the left. So, yep, I'll have 1 square extra on each side, so that will work. Because my 16s for y are going to stay 16s and I don't have any translation up or down, I'm not going to have to worry about that except for making sure I have at least 16 squares above my x-axis. So, here we go. So I'm just going to use scales of 1 unit for each. If I change my scales to anything else, things will not fit. Hopefully we realize those things before we start stuff like that. All right. So now, looking at my points, so that -2, 16 points. So horizontally, I have a 2 unit distance to the y-axis. That stretches by my factor of 4, and 2 times 4 is 8, so it's 8 to the left. Or you could look at it as -2 times 4, which stretches it to the -8. And then it translates another 3 to the left, so I count those 3, 1, 2, 3, and it ends up here at -11, 16. Then I have the point -1, 1, and this horizontal distance of 1 times 4 gives me now a new distance of 4, or you could look at it as -1 times 4 is -4, and then move another 3 to the left, 1, 2, 3. We're now at -7, 1. 0, 0 is not affected by the stretch, but it still does translate. Everything translates. So it moves here to -3, 0, and it's our new vertex. Then we have 1, 1. Now first we have to stretch this horizontally, remember, and that's on the right side. So this 1 unit to the right, 1 times 4 is 4. So we end up here at 4, and then we move back 3. 1, 2, 3. And interestingly enough, this one ends up back where it started at 1, 1. And then our last point here, 2, 16. That horizontal distance of 2 gets stretched by a factor of 4. 2 times 4 is 8. And then it moves back 3. 8 plus a negative 3 takes it to 5. So we are now here at 5, 16. So here is our function, and we can draw in our U-shaped curve here. Looks somewhat like, but not exactly, by definition, a parabola. Put our arrows on the end and finish. Here, again, it doesn't ask for a 0, but if it did, we should know that our 0 would be at or equal to negative 3. All right, after this, we got some practice problems for you to give a try. Here you go, give this one a try. Pause the video. All right, let's see how you did. So here is we have a horizontal stretch by a factor of 3. And this is our K value, so it also went up 4. So these are where our key points would have ended up. There's another practice problem that you can try. So you can pause the video to try this one. Here you go. Let's see how you did. So here, this is our A value is negative 2, so we have an x-axis reflection. We get a vertical stretch with a factor of 2. H would be negative 6, so it's going left 6. K is negative 4, that means down 4. The function here has no real zeros, and these would be our points. So negative 6, negative 4, negative 7, negative 6, so on and so forth, and you can verify. I think there's one more here. All right, let's see how you did on this one. So here we've got no reflection, but this is our 1 over b parameter, so b would be 2, and 2 is greater than 1, so we have a horizontal stretch. Here the 0 would be 0, because the vertex stays at 0, 0. All right, so that concludes this lesson, and if you have any questions, please reach out, and I will help you with your assignment. Have a good day.